He has to go save all the people. Da 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 da. I don't know why I started singing, but I like to eat bananas and grapes. I don't know why I said grapes. I really don't. It's okay. Don't worry about me. Cool. Tangent. Yay! I know you're all cheering and your arms are up in the air like you just don't care at home. I'm so excited for one day when I'm just so old and I don't know any references. This is probably already happening, but I don't know what's happening, so just go along with it. Just make me happy. All right, now for domain. Domain, again, is the x values included. Well, as I go across here, I don't have this one because that's an asymptote. I don't have this one because also an asymptote. And I don't have that one. So it kind of looks like every n pi over 2 I do not have. So I can say all real numbers except x cannot equal n pi over 2 as long as n is odd. Okay, range, it goes up and down forever, so negative infinity to infinity. The period, it starts to repeat itself after that distance right there, which is only pi. So pi, tasty, origin symmetry, which means it's odd. I have to lift up my pencil, so this is not continuous. And the zeros happen every n pi. So x equals n pi as long as n is an element of the integers. Cool. Halfway there. Alright, I'm going to go back to the front and I'm going to look at cosecant. Remember that is cosecant, not just kind of sound like a couscous, but couscous is way tastier than yeah, I don't know what that is. Anyways, it's 138. Bananas are yellow and oranges are orange. That doesn't make sense. Why wouldn't they call them yellows if oranges are orange? But then apple, yeah. Because apples could be reds, greens, or that would be confusing. But bananas would, well, they start green. They end up brown. What if they could be like greens, yellows, browns? Then you'd know it's bananas, but a lot of things start out green. Anyways, cosecant, I'm sorry. I apologize. People in the hallway laughed at me. Cosecant, don't forget this is, stop emailing me, this is 1 over sine, so it's just sine flipped. So I usually start from my sine parent function. Yo. Wasn't there a TV show called Yo Gabba Gabba or something? I don't know. I'm too old for this. Alright. So if that is my sine parent graph, and it really just flips those values, right? If I have my value at 1, I take 1 over 1, it's still 1. So that would still be negative 1. But if I have these values at 0, like 0 over 1, if I flip 0 over 1, that becomes 1 over 0, and 1 over 0 is undefined, so I would have asymptotes anytime my sine function is 0. Asymptote, totes my goats. Banana floats, pecan motes, a mote made of pecans. That would be weird looking. You're weird looking. I know you just said I was weird looking, so that was my comeback. It was totally good. I got you so good. You are the insult master. I know. Thank you. All right. So now if I take like this point, see how it kind of is at 1/2, and it's also at 1/2 over here too. If I flip 1/2, that becomes 2. 2, where is that? That is at pi over 6. Pi over 6 will be one of these. So it'll be right there and about right there. So I will have, oh no, my paper moved. That graph. Also, if you notice in this little section, kind of have like a downward parabola with sine. If I flip it, then it just goes upward. Hey! So, other way parabola, other way parabola, other way parabola, and other way parabola. Cool. That is your cosecant graph. Again, ignore the sign in the middle. You do not have to have this, just as long as you have those parabolas. The stuff in red is the only part of your graph that is actually existing for cosecant. The stuff in black is just a derivation of how to get to cosecant from sine. Hopefully that made sense. If it didn't, rewind it. Let me say it again. I don't know why I would make that sound when you rewind it. You would just click on the button. Technology these days. All right, domain. Looks like I have everything except for my pi's. So I can say all real numbers, except x cannot equal n pi when n is an element of the integers. Yay. For range, it goes up to -1. It skips this part in the middle. I don't have that. And then it goes from 1 to infinity. So I have -infinity to -1 and 1 to infinity. The period is the same as sine. This is 2 pi. Symmetry also the same as sine, so this is odd. Pretend like that says odd, not ord. I don't know what else I could say. I totally wrote that in the wrong space. This is odd. This is origin. Continuity, no way, Jose. Zeros, there are none. Cool. Pause it if I wrote too fast. Remember that you guys can pause this, go back, rewind it, rememorize these things. We're almost there. I'm so excited to stop talking so much. Yay. Secant. Secant is the opposite of cosine. This is 1 over cosine of x. So I can take all of my cosine points, banana phone, banana phone. I wonder what music is going to be like in 20 years. I'm going to be like one of those old people. Wow, that was a really bad side. Oops, sorry. Well, I guess everybody's going to be one of those old people. There's some, I don't know, whatever. Stop talking. You haven't made a video in a long time. It's been like 2 years since I made a video, so I apologize that this is kind of a weird one. But hopefully you enjoy it. Hopefully you're getting something from it. So again, anytime that you have 0, you will have an asymptote if you flip the value, because you have 0 over 1 right here, and right here, and right here, and right here. All of those, your y value is 0. So if you flip 0 over 1, that becomes 1 over 0, which is undefined, which creates an asymptote, because we cannot have undefined values. That is just simply impossible. Impossible. Okay, so there are your asymptotes. And again, we have kind of sections of parabolas, so I will take my point and make a parabola go in the other direction. Stoop-doo, 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 doo-doo-doo. Ring, 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 banana phone. Boop, boop, ba-doo, ba-doo. It's a real song, look it up. I think it's called Banana Phone, maybe. Banana phone. Yeah, I don't know. Anyways, okay, domain this one, I don't have my n pi over 2's, so I have all real numbers, except x cannot equal n pi over 2, as long as n is odd number. Okay, range goes same thing as the last one, so from -infinity to -1, and union 1 to infinity. Period. After 2 pi it repeats itself. Symmetry is y-axis. This is even then, not continuous, and no zeros. Ooh, one more, almost there. I'm sorry this is such a long video, but hopefully it is being helpful, because you are basically sitting through my lecture and I am lecturing again. I don't know how many times I've taught this lesson now. I'm thirsty. Oh. I got this pink gorilla. It's supposed to grow. I don't think you can see it, but it says, yeah, you can't see it, but it says Taiwan on the back, so I'm really excited to put it in water and watch it grow, and then have it say Taiwan just really big. So that's exciting. Anyways, cotangent is the opposite of tangent. 1 over tangent of x. And I know tangent goes here, does something like that. Where pi over 2, I have my asymptotes. So if I flip these values, again at my zeros, I will now have my asymptotes. That's really hard to see. So every pi, I will have an asymptote. All right, cool. And then where I had my asymptotes, those were 1 over zeros. So if I flip 1 over 0, that becomes 0 over 1. So now I have my zeros at pi over 2. Also, don't forget on your unit circle, cotangent is x over y. So if I do 0 over 1 up here at pi over 2, that will be 0. Okay, and then it will go the opposite direction as tangent. Do-do-do-do, do-do-do-do. I'm so excited to be done. I love you guys, but man, this is tiring. And I can't pause it, so I can't take a break. Okay, I'll stop complaining because you guys complain too sometimes and I tell you not to complain. So I don't complain either. I'm so excited, you guys. Yay. Woohoo. Okay, domain. I have cannot be at pi, cannot be at pi, cannot be at pi, the whole number pi. So I have everything, all real numbers, except x cannot equal n pi as long as n is an element of the integers. That was a bad one, but it still looks good. There's a little space in that z. That's kind of hard to see, sorry. Range goes forever and ever, so negative infinity to infinity. Period is also pi. Symmetry is origin, which means it's an odd boy, not continuous. Wow, that says no. Oh gosh. Zeros happens at every n pi over 2. So x equals n pi over 2, where n is odd. And there is cotangent. Hopefully this video has been helpful. I didn't really tell you guys when this stuff is useful, but check it out. I'm not signing in. Sine and cosine waves. Sine and cosine waves. Yeah, there they are. You believe me. Electrical. Sure. That's... Oh my gosh. Oh my gosh. What's happening? I don't know. What is .com? Sine wave, cosine wave, ampere. Yeah, I should have looked this up before. I'm sorry. An introduction to signals. Yeah, this is signals. I mean, radio waves are sine and cosine. Radio waves from space. Those aren't very good. Yeah, see, kind of like that. When it sends out signals and it sends them out in beeps. So every now and then there's a peak. Here you go, something like that. Radio waves, radio waves. Yeah, you guys have seen this. I know you've seen this. But I mean, those are sine and cosine waves. We kind of zoom in on those images to turn on gene expression. Yeah, I don't know what that means, but anyways. But yeah, I mean, penetrate deep tissues, making them ideal for manipulating cellular signals. So cool. That's actually sounds like how they do like the radioactive treatment of people that have cancer and stuff like that, if that's even around by the time that this video is seen by you guys. But yeah, there's lots of different uses for them, especially if you guys go into engineering. I just think they kind of look cool, as I do with everything in math, because it just analyzes patterns that we see in real life. Anyways, I hope this was helpful. Love you guys. Whatever questions you got, don't forget that you can pause the video, rewind it, rewatch it, whatever you want to do. Come ask me questions, anything and everything. There's some cute monkeys for you. I bet if I type cute monkey, it's even cuter. Oh, he's holding a tiger. Oh, that's one on my background. Oh, I like those ones. Yeah, that's one. Oh, look at that guy. That guy has a cool mustache. He's really happy. That guy just caught a really big fish. That's actually not a monkey at all. That's just a baby. All right, I'm going to sign off. See you guys later. Bye-bye.